What is the difference between quality control and quality assurance?
Sir, quality assurance is just you uh, you make sure that your product there is no defect. But on the other hand, quality control is just you have produced the product and then you are trying to identify if there is a defect or not.
Okay. So quality control means that you'll produce the product first, and after producing the product, you will check the output whether the output is defective or not. On the other hand, quality assurance means that you will not only check the output after production, you will also control the quality during the total production process from inspection of raw materials to inspection of finished output. And total quality management that we have discussed in our previous lecture, total quality management and quality assurance is almost synonymous. Total quality management and quality assurance is synonymous. But in today's world, when we say quality control indicates quality assurance and also total quality management. However, traditionally, quality control means inspecting the output only and identifying whether there is any error or defect in the product. And statistically, what are the different tools to check the defectiveness or to check the quality of the product? Today we're gonna discuss about the statistical tools. In our previous lectures, for example, quality management, we discussed about the different dimensions of quality. But today, we're gonna discuss about the statistical tools used to control the quality, and especially this is known as statistical quality control or statistical process control, SPC, and statistical quality control, SQC. SQC is popular word like TQM. SQC means statistical quality control. So can you hear me all right?
Yes, sir.
Okay. Then maybe the internet connection or the internet problem has not solved nationwide problem. Still I am facing problem also in mobile connection, mobile data. So let's begin. Quality control. Quality control, first approaches to quality control. Approaches, we said that quality, this is quality control and this is quality assurance. As we have begun with, quality control means that you will inspect the output only, inspection alone. And continuous improvement or total quality management or quality assurance is referred to as the quality built in or quality built into the process. It means that everybody in the organization will do their job properly, and if everybody is involving or maintaining quality in their job, the output of this system will also be defect free. That is also known as continuous improvement or total quality management. So total quality management, it says that it is the most progressive system and it is the least progressive system. That means you will only inspect the output. It is least progressive quality control system, and in today's world, from beginning to end, you control the total process control. So input control, process control, and then output control. Here it covers only input control, and here the most progressive technique, continuous improvement or total quality management, covers inspection of inputs to inspection of process to inspection of output, and the quality is built into the system. Quality is built into the system, and if we can apply the total quality techniques, you know what is total quality techniques and what are the different contributions of quality. Quality plan, quality control, quality improvement. If you have the plan, if you have control techniques tools, and then you can make sure that the output is gonna defect free or continuous improvement or TQM. And TQM or continuous improvement is the most progressive technique, and quality control is, you know, least progressive technique. Quality control, here we indicate that inspection of the output after production. There is no process control here. So which one is better? Quality assurance or continuous improvement, or only inspection or quality control? What do you think?
Continuous improvement.
Continuous improvement, because it is most progressive. Everybody is involving in the quality control process, and the quality is built into the system. That means when you are producing any product, the product will be defect free or will not be defective. And statistical quality controls, we usually can control the quality in using three different statistical tools. The statistical tools that we use in quality control, here we indicate quality assurance. To assure the quality, continuous improvement, total quality of the product, we use three different types of statistical tools. And the three different types of statistical tools includes, number one is descriptive statistics. You know, descriptive statistics known as the central tendency analysis, or it is known as the average, standard deviation, and range. These are the basic descriptive statistics. And what is mean? You know, mean means average, and we calculate average sum of x divided by n. If we want to know what is the average age of the students in your classroom, then you will sum up all the ages of the students and you will divide by number of students. And the standard deviation is the deviations from the average. Your average age is 20, but when I have chosen you, then your age is 18. So it is -2, and this is ultimately the standard deviation. And the standard deviation, when we check standard deviation, we take the deviations or average of the deviations, sum of xi, your age, minus x bar plus square divided by n root over standard deviation. That means plus minus 2. If the standard deviation is plus minus 2, it indicates that the average age of the student is 20, but some students are more than 20, some students are less than 20. Involve inspecting the output from a process. Quality characteristics are measured and charted, helps identify in-process variations. And you know that we can use different types of chart that we describe in our previous lecture. And then statistical process control. Statistical process control, ultimately today we will discuss about the statistical process control, or SPC. When you are producing a product and the output is coming out from the product. The product, we wanna have the product defect free, and that means you have to control the process while you are producing the product. It is known as the statistical process control, and we will use some statistical tools. The statistical tools include, say for an example, control chart. Control chart that we introduce you in our previous lecture, tools of quality control. Control chart is one of them. We'll use control chart today, and how to calculate control chart we are gonna discuss. And the third technique of statistical quality control is acceptance sampling. Acceptance sampling, operations management means input, transformation, and output. And acceptance sampling is only applicable at the beginning of the production process and at the end of the production process. When you are using inputs, you will check whether the input quality is okay or not. To check that input quality, you will take some items from the input and then you will check it. And if the quality of the chosen sample is fit, then you can say that the all inputs are fine. It is known as the acceptance sampling. That means you will take several samples and then you will declare that based on sample, all inputs are fine. Similarly, acceptance sampling is also equally important for the outputs. When you have produced the product, you have to choose, or you have to take several samples randomly, and you have to check the random samples. And the random samples will say whether the all products are defect free or not. If all the sample you have taken are defect free, you will conclude that all the outputs produced from the system is also defect free. So acceptance sampling used to randomly inspect a batch of goods. That means you will choose several product sample, and then you will determine whether total product is acceptable or total product is not acceptable, or acceptance and rejection do not help to catch in process problems. But acceptance sampling does not do anything for the process control. So today we will ultimately discuss about the process control and development of the control chart that is used to know whether the process is in operation or not. And descriptive statistics, as we say, that the descriptive statistics includes, number one is average, mean, sum of x divided by n, and you know how to calculate it. Range, difference between the smallest and the largest observation in a data set. So for an example, the lowest age in your class is 17 and the highest age in your class is 21. So range is 3. Highest and lowest, difference between the highest and lowest observation or value. And standard deviation, as we said, that your age is 18, but the average age of the class is 20. So your age 18 minus 20, average age, x bar. And you will take the deviations of all the samples, xi, all the samples, all the students, and then you will divide by n or n minus 1. Both are same, n or n minus 1. So standard deviations, you will calculate the standard deviations to know the deviations from the average, And usually the data we deal with is normal data. Normal distribution, you know, means that 3 sigma, 6 sigma, can you remember? Normal distribution means that the age of the students, example, the age of your individual age, your age, your friend age, your age of the classroom will be around average. Average age is 20, so the ages will be around 20 and will be distributed in a bell-shaped form. And usually we describe normal distribution like this. Normal distribution, bell shape. It is look like a bell, and it is the average. It is the average, and all the observations will be within the, within the limit. And usually we say it is, if you can remember that 3 sigma. 3 sigma means that plus 3 sigma minus sigma. If the standard deviation is 3 sigma 3, it means that your 99.74% data is under coverage. 99.74. What does it mean? It means that your average age is 20, average age is 20, and if the standard deviation is 3, plus minus 3, plus minus, standard deviation is always expressed in plus minus. Plus 3 is over here and minus 3 is over there. So if the standard deviation is out, then your all of your ages will be here within this limit. Someone will be more than 20, but not more than 23. If it is more than 23, the ages will be somewhere here. That means we can easily identify that maybe you are not the student of the classroom. Or if it is below 17, then we also say that you are not the student of this class. Mistakenly you have entered the classroom, or you have some academic problems. So standard deviation is used to calculate the deviations from the average, and when we depict the average standard deviation in a picture, it is usually normal. It may be skewed. If it is skewed, then it also, say for example, this is positively skewed. There may be negatively skewed. That is also normal, and usually we use the normal distribution. We use the normal distribution to describe the product quality. So descriptive statistics means that the product that you are going to produce, you will check the quality of the product. Quality, when we say quality, it indicates that it is defective or not. So quality control means ultimately identifying whether your product is defective or not, whether your product is standard or not. So descriptive statistics we will use in our quality control process as the measure of quality, or defective or not defective. So there are 3 methods. One is descriptive statistics, another is statistical process control, and another is acceptance sampling. Acceptance sampling acceptance sampling is only applicable for the inputs and outputs, and descriptive statistics can be used for inputs, outputs, and transformation, and only for transformation process. To check the quality of the transformation process, we'll use statistical process control. Let's come to the definition of statistical process control. Statistical process control means that you will control the quality of the output during the production process. And SPC or statistical process control methods includes control chart. Control chart is one of the powerful tools used by the operations manager to control the quality of the output. And control chart is like this one. This is one of the examples of control chart. Control chart can be developed for two different types of control chart. Two different types of control chart. One is known as the control chart for variables, and another is known as control charts for attributes. What is control chart for variables? Control chart for variables means that you will apply the control chart, or you will develop control chart for variables when the characteristics of the output can be measured, or can be measured through length, weight, diameter, time. Say for example, weight of the students, weight of the product, weight of the content of a bottle, water bottle content. So variables means that which have variations, variable, and we can use, that means with variable and attributes. Variable means the output that can be measured, and if the output during the quality control process cannot be measured, then you will use attributes. This is also known as the discrete values. Say for example, percentage of defect. So percentage of defect like length, weight, diameter, it cannot be measured. What measure means that there is a measurement, 5 ounce, 5 kilogram. Defect percentage cannot be measured. Number of flows in a shirt, number of spots in a shirt. A spot, there is a spot or not. So we are getting the answer yes or no. Defective or not defective? Yes, no. It is known as discrete or attributes. When the variable cannot be measured, only be counted, this is known as the attributes. And if the output is attribute, if we check the quality of the attributes, then we will apply different techniques for control chart. And if the output or the materials for which we are gonna developing control chart or controlling quality, control chart means that we'll use a chart to control the quality of the product. We will apply variables for the control chart for variables when the output nature is length, weight, diameter, time, and can be measured. And attributes means you cannot measure. You can only say yes, no, good, bad, accept, reject, defective, non-defective. This is known as attributes. And control chart usually, if you can remember the average age of the student. What is the average age of the student in your classroom? Maybe 20. 20 is your average age of the student, and standard deviation is 2 plus minus 2 plus minus 2. So in that case, what will be the upper control limit? What will be the upper control limit?
So 22 is the upper
22.
limit.
And what is the lower control limit?
18.
18. Yes. Lower control limit is 18. So it is known as the control chart. It is known as the control chart. Now it comes to me to check the quality of the students. To check the quality of the student means that whether someone is entering the classroom and I have asked him what is your age, and he or she said that my age is 23. 23. So you become outlier, and I will check whether you have ID, you are really the student of my class, or you have made any mistake. Similarly, when the operations manager check the quality, they develop this type of control chart. The average of the output, say for example, average weight will be 20 ounce here, 20 ounce. When any output that will be above the upper control limit, UCL, upper control limit, then the operations manager will ask the production officer that what happens. One product I have seen in my computer, because you can in today's world can check the product quality in your dashboard. And every output, whether the output is within the limit or not. If it is within the limit, there is no problem. The operations manager will not ask to the production officer. But when they will find any item that is out of the upper limit or out of control, then the operations manager will ask to the production officer what happens there. There may be some problem in your production system, because I saw that some product is out of my control. And when it is out of the control, that means the product is defective. Are you getting the point? What is control chart? Is it clear what is control chart?
Yes, sir.
And what is variable and what is attribute? Variable means the value can vary, and usually the variables we can measure using length, weight, diameter, and time. Say for an example, this is a water bottle, isn't it? What is the content? The average content is 250 ml, 500 ml. Average content is 500 ml. Ultimately, 500 ml is not here. There is a standard deviation, a standard error. Maybe point plus minus 5 gram. So if it is plus minus 5, maybe up to this point, plus 5, and minus 5 up to this point. So upper and lower, if the content is within the limit, control limit, is all right. But if it is more than the content, what will happen? You cannot use this cap. At the next stage, when the bottling will be finished, that means cap will be given. The cap system will not work, or water will flow down, and there will be problem in the next stage. So when you will find any problem in your production system, immediately you will check what happens to the previous steps before going to the next step, because if it passes to the next step, then again more problems will create in the system. So it is also variable. Because we can measure the content to 50 ml. But when we will check whether this bottle is defective or not, then it is attribute, whether it is defective or not. Then we will use attributes, control chart development for attributes. We are differentiating variables and attributes, and you have to understand, because The control chart development. Control chart development depends on the nature of the product that you are going to test. So that's why understanding variable and attributes important. Now we'll discuss about the quality control chart development for the variables. Quality control chart development for the variables. When we will develop the quality control chart for variables, that means when we will use quality control chart for, this is the central line, this is known as CL, central line, and there is a upper control limit, UCL, upper control limit, and there will be a lower control limit. When we will develop such type of chart for variables, we can develop such type of variables using X bar chart or R bar chart. X bar chart means that average and R bar chart means range. X bar chart means average and R bar chart means range. That means the central line will be the average, or maybe the central line may be the range. So when we'll use X bar, then we'll say this X bar chart. When we'll use R bar means average, isn't it? So average of the ranges. So when we'll use R bar chart, here we'll say it is R bar chart. Let's discuss how to develop X bar chart. This is the example of developing a X bar chart. A quality manager, a quality control inspector at the COCO of his software company is going to test the quality, and he has taken 1, 2, 3, 4 observations, 3 samples, 1, 2, and 3, 3 samples and 4 observations. Sample means that, say for an example, sample 1. If we say that we want to know the average age of the students of NSU, not your classroom. The previous discussion was the average age of the class. Now average age of the NSU student. So when we gonna know what is the average age of the NSU student, what you have to do, you have to take samples from different classes. Say for example, if you have the undergrad class, then we will take some samples from your class. Maybe 4 students age. We'll take 4 students age, 4 observations. Then I will take 4 observations from MBA class, MBA. All right. Then I will take observations from MSc. So we are getting bachelor, we are getting masters, or maybe we are PhD here. MSc is also masters, PhD. We are also going to know the average age of the students of NSC. So what you have to do, you have to take samples, undergrad and masters and PhD samples, and in each sample you will take 4 PhD students, you will take 4 master students, you will take 4 undergrad students. Then you can get, this is the average of each sample. So sample 1, sum of the figure will be 15.8 plus 16 plus 15.8 plus 15.9 divided by how many observations are here? 4. So it is X bar for sample 1, it is X bar for sample 2, it is X bar for sample 3. All right, are you getting? These are all
Yes, sir.
averages. And you can also check the range. This is the range of sample 1.2. The highest is, what is the highest? Highest is here 16, and the lowest is 15.8. So the range is
15.8.
0.2. Here the highest value is 16.1 and the lowest is 15.8. 0.3. Here 16, highest, lowest is 15.8. So the range of 3 samples
2.8.
here. Now what you have to do for X bar chart, what we are gonna do, we are going to deal with the control chart development for the variables. And for variables, we can use X bar chart or we can use R bar chart. When we will use the average, then it is known as the X bar chart. When we will use the range, it will be referred to as the R bar chart. All right. So what additional information we need? So there are 3 samples and with 4 observations. Each of the volume of Burroughs field, if the standard deviation of the modeling operation is 0.2, this is the population standard deviation. This type of standard deviation is usually the operations manager maintains. That means operations department is maybe not be a new department, maybe an old department. So standard deviation from the previous experiences will be summarized here. Here, the standard deviation, the operations manager said that is 0.2 ounces. And the below data to develop control chart with limits 3 standard deviation and the normal distribution. Normal distribution will be 3. 3 standard deviation is expecting. Through standard deviation, you may know that the observations will be within the limit. 99.74% of the observations will be within the normal distribution curve. And standard deviation, and this standard deviation is for 16 ounce. The average is 16 ounce. Now we will calculate the we'll develop the X bar chart. When we'll develop the X bar chart, we will calculate the average of the averages. Central line. How will calculate central line? Here 3 line in control chart development. 3 line. And this is known as the X bar line or central line, CL. Central line. How you will calculate central line? You will take the average of the averages, and average of the averages is referred to as X double bar. So X double bar, X1 means 15.875 plus X2 means 15.975 and Xn means 15.9, and you will divide by number of, K means number of. How can you get the X bar? Number of samples, isn't it? Are you getting?
Yes, sir.
Okay. So X double bar is clear. Then you will calculate the standard error from this data available. And to know the standard deviation of the X bar, standard deviation of the X bar, we'll use standard deviation given here, 0.2 ounces. 0.2 ounces. And we'll use N. N means here number of observations. How many observations in each sample? 4. Isn't it? Sigma means 0.2 ounce divided by root over 4. Then you will get the standard error. And the standard error will ultimately help you to write the upper control limit and lower control limit. So can you calculate now central line, upper control limit and lower control limit? Can you please do? And if you do it, it will make clear whether you have got the idea or not. Please.
Sir, in the UCL formula, what is Z here? Like X
You
over
see,
plus
BTL
Z.
means it is X bar and then standard deviation. And standard, when you use the standard deviation, this standard deviation you'll get, isn't it? For control chart development in quality characteristics, the Z value, we'll use the Z value specified here. That means whether the distribution is normal with 3 standard deviation, 2 standard deviation, or 1 standard deviation. And usually we use 3. We use 3 because 3 covers around 100% observation. All right.
So we use
Covered
3 in place
100%
of Z, right?
observation. And sorry.
So we will use 3 in place of Z, right? And we'll put the value
The
3.
information will be given because this also depends on the manager's experience. If the manager say that yes, through standard deviation covers almost 100%, 99.74%. So you will use Z. If the operations manager gives information here that the standard the two standard deviation covers or describes the data better. So it is ultimately the description of the data or what we have said that normal distribution. Normal distribution, the data is around the average normal distribution. So we'll similarly, if your age is standard deviation is 3, so then you will use X bar plus minus 3. Here same thing, X bar, X double bar, as a lot of samples are involved. X double bar plus minus Z sigma X bar. Z sigma X bar you will calculate from here, and Z, the information of Z will be given here. So can you try now? And if anything else, then it will be clear to us whether you're getting or not. Can you please develop a control chart? Can you try? Hello, gentlemen, can you hear me?
Yes, sir.
Can you try? So, Mr. Fadin Muhammad Rizwanul Haq,
Yes, sir.
what is the grand average here?
Sir, there is a bar. Sorry, sir.
What is the grand average here? X double bar means grand average. What is the grand average here? What's the grand average? Average of these 3 averages. 15.875, X1, X2 is 15.9.
15.975 and sir 15.9.
15.9. Then what divided by K? K means number of samples, because you are calculating the average of the 3 samples, isn't it? Divided by 3.
Yes, sir.
And standard error.
3.
Mr. Zarif, what is the standard error? Or
Sir, it's 0.1. It is 0.1.
Here 0.2.
0.2 divided by root over 4.
Root
Sorry,
over 4,
yeah,
number
root
of
over 4.
observations, right? And then what is the upper control limit and lower control limit?
Sir, again, I'm asking, sir, what will be the value of Z here? Will it be 3 or will it be 0.9974?
3. Z means you will use 3.
Okay.
What's the upper control limit and what's the lower control limit?
So the upper control limit is 16.21.
And lower?
So the lower control limit is 15.61.
Mr. Ahmed Zawdul Islam. Are with us? It's all right. X bar means average of the averages, and the control limits for three signal limits is upper control limit 3.2 root over 4, or the standard error you already calculated 6.22, and lower control limit is 15.62. So this will be the central line. If we draw the control chart, this will be the central line, and this will be the upper control, and this will be the lower control limit. All right, this is how we'll develop the X bar chart. This is how we'll develop the X bar chart. Now, R bar chart. X bar chart is clear to you?
Yes, sir.
Yes, sir.
Then go to R bar chart calculation.
So can you go to the previous slide?
Previous slide.
So R bar calculation.
Very slow. Just a moment. What happens? I don't know. Slide is not. Oh yes, I forget. I need to change the mode. Here. Yes, this is the previous slide. Any problem?
No, not a problem, sir. Just trying to find out the average of R.
Oh yes, average of R. Thanks. So for R bar chart, yes. For R bar chart, we will calculate the average of R bar. So what is the R bar here?
So 0.233.
0.233 R bar.
33.
So go to the R bar chart development. Very slow. This is because of poor internet connectivity. This is also X bar chart. Some examples, more examples are given, but we will look into R bar chart now. And for R bar chart development, we will just use, chart. You do not need to calculate standard error, because using range, calculating a standard error is difficult. You can calculate the standard deviations, but calculating a standard error is difficult. That's why what we'll do, we'll use this type of chart. So, say for example, R bar chart development. Here, 10 samples with 5 observations each have taken from the Crunchy potato chip company planned in order to test for the volume dispersion in the bagging process. The average sample range was found to be 0.3 ounces. So, average sample range is given average that you have already calculated. The average sample range is 0.3. Develop control limits for the sample range. So what is the here? The average central line is 0.3 ounces. Are you getting? And you need to know the number of observations. 5 means what? 5 observations each.
Number of observations.
Observations n, because k we use two terms k and n. K means number of
Number of sample bars.
samples and n means number of observations. So we'll use n, number of observations, and we'll use a different chart. The chart is developed by the statisticians to calculate the upper control limit and lower control limit. And D3 of the chart is upper control limit, and D4 is the D4 is the upper control limit, and D3 is the lower control limit. And when D3 is 0, lower control limit is minus, then we will use 0, or we can, if there is a minus figure, then we will also use 0. Just a moment. What is gonna happening? If I change the internet, then maybe I lost my thing. What does it mean? Sorry, just a moment.